Hi, today we're going to go through this chapter 1 on Introduction to Switched Networks. For this chapter, there are 4 parts. The part 1 is this introduction to the switched networks. Part 2 will talk about how switches are used in a typical LAN design. Part 3 will talk about the details of how switches are used in LANs. And finally, we'll wrap up with a summary of this chapter. For this chapter, we have the following objectives. We will cover the convergence of data, voice, and video in a typical switch network. We'll also talk about how the switches are used in small and medium-sized businesses. And third part, we'll talk about the concept of frame forwarding in a switch networks. And finally, we will talk about the discussion of collision domain versus the broadcast domain. For the purpose of the exam, the more important part will be the part 3 and part 4 on the concept of frame forwarding and the differences between collision domain and broadcast domain. So in general, our computer networks are getting more and more complex because we have more information to be transmitted across the network. In general, a converged network refers to the collection of information between devices such as your IP phones, your video conferencing support, and also other features such as your voice messaging for mobility and so on. All these information are controlled in the network through a converged network. The benefits of a converged network includes a substantial savings through the savings such as the installation and management of separate systems for voice, video, and data. It also simplifies the management of the IT systems. So in general, IT networks can be classified in the following way: what we call the core, distribution, and the access layer. The core layer is actually a central systems where it's actually transmitted systems to other networks such as a wide area network. For the distribution layer is talking about the layer in the middle where the telcos actually collects the information between the end devices and sent through the core layer. For the access layer, we have the information collection from the end devices such as your PCs, your mobile phones, etc. So the roles of a switch networks are very crucial in a network design because the switches allow the more flexibility in a switch networks, and it allows more traffic management so that more traffic can flow through efficiently in the network. It also allows the management of quality of service through the measurement of how good a system of a network, and additional features such as your security, wireless networks, and IP telephony and mobile services. So in terms of a purpose of the exam, this is a typical good way where we can ask questions such as the questions on what are the advantages of a typical switched network. The switch works in the following ways. It makes a decision on how to transfer the message from the source port to the destination port. The LAN switch keeps a table that allows it to decide how to forward the traffic through the switch, and the Cisco LAN switches will forward the Ethernet frames based on the destination MAC address of the frames. Let's take a look at this example. Suppose we have a switched network consists of 3 PCs shown in the diagram. PC1 sends frame that it wants to transmit to the destination, but the switch receives the frame. It has to decide where does it send to. Is it to PC2 or to PC3? So in this case, the switch has to make a decision. How does it know where to send? In this case, the switch will build a table of information. In this table, it will consist of the source and destination info. So through the table, the switch will know where to send from the source to the destination device. So the table consists of the source and the destination information. So let's say in this case, the source is AA:BB:CC hardware address, and the destination hardware address is AA:BB:DD. Where does the switch get all this information from? This is taken from the frame header itself. When the switch reaches the frame header, it will be able to get all this information and send to the destination in this case. So in the previous slide, we have seen a very simplified explanation of how the switch forwards the frame from the source to the destination. Here are some details of how this is done. In general, the switch will need to learn the device that exists on these ports of the switch, and after that it will build a table known as the MAC address table. Using this MAC address table, it will map to the correct device that is located on the port of the switch. This is used for what we call the high-speed searching in the switch, and the MAC address table is able to send the frames efficiently to the destination address. However, if the switch is unable to find any MAC address on the MAC address table, it will simply flood the frames to all the ports so that hopefully it will find the rightful destination for the frame. Let's take a look at the previous example shown earlier. Assuming now PC1 sends a frame with a destination MAC address of AA:BB:FF. So now the destination MAC address is sent to the switch. The switch will compare the destination MAC address with its own MAC address table. But based on the MAC address table, it is unable to find any destination MAC address that fits this frame. So what the switch will do is it will simply send the frame to all other devices in this network except the original device, because this is where the original frame comes from. So it will send the frame AA:BB:FF to PC2 and PC3, and hopefully one of them will be the correct destination for this frame.